This is a revision video on visible light. Visible light is part of the electromagnetic spectrum, and you can see it starts off with a long wavelength, gets shorter and shorter and shorter. Visible light's around the centre, and what I've done is I've zoomed in here and then zoomed out. Visible light, white light, if we look at light it looks white to us, but it's actually made up of all the different colours. So red, orange, yellow, green, blue, indigo and violet, and the way you remember this is Roy G. Biv. Red has got the longest wavelength of 700 nanometers, and violet has got the shortest wavelength of 400 nanometers. Remember, nano means times 10 to the minus 9 meters. So 700 times 10 to the minus 9 meters is the wavelength of red. So white light is all these colours at the same time. If you add all these colours together, you get white light. However, if you don't have any colours at all, it appears black. So black is no colours at all being reflected. No colours reflected. And lots of materials depend on the wavelength. So some materials only absorb certain wavelengths if we go back to the colours. So for example, if a material absorbs all colours apart from 700 nanometers, it will appear red. So for example, if we were to draw an apple, a red apple, so red apple, what happens, we have all those colours coming in, red, orange, yellow, green, blue, indigo and violet. So all those colours are coming in, they all get absorbed apart from the red. Only the red is reflected, and that's why the apple appears red. That's why a purple t-shirt appears purple, it only reflects the purple light. Or it could be because of the colours combining. For example, a banana could look yellow because it reflects both red and green. Red and green make yellow. We can also use filters to only get a certain colours going through. So for example, if we get a blue filter, so we've got a blue filter, and what a blue filter does is it only allows blue light through. So red light is absorbed, orange light is absorbed, yellow light is absorbed, green light is absorbed. But because blue light is the same colour of the filter, blue light is transmitted. Indigo is absorbed and violet is absorbed. So the colour of the filter only allows that colour to pass through, only allows that colour to be transmitted. So for example, if we were to go back to our red apple example of a minute ago, there's our red apple. If we were to put a blue filter in the way, so we've got all the colours coming in, so we've got white light coming in, only the red's reflected. Only the red's reflected off it because it's a red apple, it's absorbed all of the colours. But because red isn't blue, red cannot pass through that filter, so what the apple actually looks like through a blue filter is it looks black, because the red light that it's reflected is not transmitted by a blue filter, no colour at all, so it appears black. So if we look at another example, so let's have a white t-shirt. A white t-shirt, and all the colours are going to be on it. So red, orange, yellow, green, blue, indigo and violet. And it's a white t-shirt, so all colours are going to be reflected too. So red, yellow, I missed out orange, so I'll put orange in now, orange, green, blue, indigo and violet. And if we were to arbitrarily put a green filter in the way, so we put a green filter, it only allows the green light to go through, so that t-shirt will look green to us. So to recap colours, if something looks blue, it's only reflecting blue light, or it's reflecting the colours of light that add up to blue. If you put a filter in the way, that only allows light to transmit of the same colour as the filter. For example, if we've got a white t-shirt, all the colours are reflected because white light is all the colours. If we put a green filter in the way, only allows the green light to transmit, so it appears green. If we swap that green filter for a violet filter, it would only allow the violet light to transmit, so that t-shirt would look violet. And that is the revision video for colours.